Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you Algebra 1. And in this video, we're going to continue on our quest in solving systems of equations by substitution. And in exercise number 3, it says that each of the examples in exercises number 2 were presented where one variable was already isolated. We worked with 4 different parts of exercise number 2, and every single part had a variable that was already isolated. So if you didn't go through each of those exercises, I suggest you go back to exercise number 2's video and you take a look at those equations and that solution. It would be extremely helpful in looking at this exercise right here, because this will not always be the case. How would we go about solving this system of equations here? So I would go about it, since I know how to solve by substitution, by isolating a variable. So I'm going to isolate the y variable down here, just because that's the first one that seemed the easiest for me to isolate, which means 2y plus 3x is equal to 7. I don't know what y or x equals, so I need to find out what it's going to equal. I'm going to subtract 3x from both sides. I'm going to get 2y is equal to negative 3x plus 7. And then I'm going to go ahead and I'm going to divide everything over here by 2, which will give me y is equal to negative 1.5x plus 3.5. So we have what y is equal to in this equation. So we're going to take that value of y and we're going to substitute it into y up there. So what we want to do is now we want to take the first equation, which we haven't touched yet, and we'll have 8x minus 2 times y, which we now know is negative 1.5x plus 3.5, and that's going to be equal to 4. So now we could go ahead and we could simplify this as 8x negative 2 times negative 1.5 is going to be positive 3x. Negative 2 times 3.5 is going to be negative 7. And that's going to give us a equal 4, and then that's going to combine to be 11x minus 7 is equal to 4. We could add 7 to both sides to find the value of x. We'll be left with 11x is equal to 11. Finally, when we divide by 11, we'll get x is equal to 1. And that's going to be our x-coordinate, 1 comma something. And to find that something else over there, we're going to have to now choose either equation. I'm going to go ahead and I'm going to choose this bottom equation, 2y plus 3x equals 7 to find my y value. But now I know my x value is 1. So I'm going to go ahead and I'm going to substitute in 1 for x. And that's going to be 2y plus 3 times 1 is 3 is equal to 7. I subtract 3. And I'll get 2y is equal to 4. Finally divide each side by 2. And they'll give me a y value of 2, which means the intersection point of these two lines would be at 1, 2. Now, it might have been tedious for us to isolate a variable here and then substitute it into an equation, and then after we've found the x value to substitute that value back in for the y value. Lots of substitution. Oh, wait. That's because it's called systems by substitution. It's catching on, right? Okay. But in lesson 3, in our next lesson, we're actually going to learn how to solve a system of equations by elimination, our third and final method of solving systems, for examples that are in this form above. We won't have to isolate a variable by itself unless that's something that you're comfortable doing, and you could choose to use that method over the other ones. Okay? So at this point, we've now looked at not every possible, but many possible scenarios of systems of equations by substitution. And if this video was helpful in solving a system of equations that did not have a variable isolated already, give it a thumbs up, and you're ready for exercise number 4 by clicking on the link in the video provided. Thank you for watching.